Students, we have studied that an ionic bond is formed as a result of electron transfer, and metals and non-metals participate in bond formation. Yes. Covalent bond is another important type of chemical bond. Then different theories have been given to explain the formation of covalent bonds. Yes, the important theories are: number one, Lewis-Langmuir theory. Lewis-Langmuir theory. Okay. And number two, valence bond theory. Its short form is VBT. And number three, molecular orbital theory. Short form is MOT. Okay. These theories, Lewis-Langmuir theory, valence bond theory, VBT, molecular orbital theory, yes, explain the formation of a covalent bond in a molecule. Okay. Yes. Today let us discuss the first theory, Lewis-Langmuir theory. Yes. Langmuir, in collaboration with Lewis, introduced a new type of bond in a molecule is known as covalent bond. What is meant by covalent bond? Or how a covalent bond is formed between atoms? A covalent bond is formed by the mutual sharing of electrons between two atoms. A covalent bond is formed by the mutual sharing of electrons between two atoms. Okay. Yes. Let us discuss some important examples for the formation of covalent bond. The example 1. Formation of chlorine molecule, Cl2. The chlorine molecule is formed by the combination of two chlorine atoms. We know the atomic number of chlorine is 70. The atomic number of chlorine is 70. Then its electronic configuration is 287. Chlorine atom has 7 electrons in its valence shell. Okay. Then here each chlorine atom requires one more electron to complete octet to equivalent electron configuration. Then when a chlorine atom combined with another chlorine atom, okay, the one electron of chlorine is shared with one electron of another chlorine atom. Okay, then here one pair of electron is shared between two chlorine atoms. Okay, then here each chlorine atom contributes the same number of electrons. Okay, then to form a common pair, common pairs which are then shared by both atoms, then each of the atom acquire octet configuration, stable electronic configuration yes, of the stable configuration of the nearest noble gas. That means each oxygen atom has 6 electrons in its outermost shell. Therefore, we can say that each oxygen atom requires 2 more electrons to attain the stable electronic configuration, the octet configuration, or the nearest noble gas like electronic configuration. Then, here the first oxygen atom shares its 2 electron with 2 electron of the second oxygen atom. Okay, here the 2 pair of electron is shared between 2 oxygen atom. This 2 pair is common for the oxygen 1 and oxygen 2. That means 2 plus 2 plus 4, 4 plus 4, 8. The first oxygen atom acquires a 8 electron configuration. The second oxygen atom also acquires 8 electron configuration. And the third example is formation of N2. Formation of a nitrogen molecule. Nitrogen molecule is formed by the combination of 2 nitrogen atoms. Okay. The atomic number of nitrogen is 7. Its electronic configuration is 2, 5. That means nitrogen atom has 5 electrons in its valence shell. Okay. Then we can say that each nitrogen atom requires 3 more electrons to complete octet configuration, 8 electron configuration. Then, yes, when 2 nitrogen atoms combine together, the 3 electron of the first nitrogen shared with 3 electron of the second nitrogen. That means 3 pairs of electrons shared between 2 nitrogen atoms. Okay, this 3 pair is common for both nitrogen atoms. 3 pair means we have 6 electron. 6 plus 2, 8 electron. First nitrogen acquires 8 electron configuration. The second nitrogen also acquires 8 electron configuration. Okay. Then the covalent bond can be classified into 3 types: single covalent bond or single bond, double covalent bond or double bond, triple covalent bond or triple bond. Yes, we can say that the covalent bond is formed by the sharing of 1 pair of electron. Sharing of 1 pair of electron is called a single bond. Here the between the 2 chlorine atom, 1 pair of electron is involved in sharing, then here forms a single bond. Single bond, we can represent the single bond, okay, using a single line like this. Okay, Cl single bond Cl. Cl single bond Cl single bond. Then in the case of O2, 2 pairs of electrons are involved in sharing. Here the bond formed is double bond. Double bond or 2 line or double bond or. Then in the case of N2, 3 pairs of electrons are involved in sharing. Yes, then N triple bond N triple bond N. Okay, yes. That means the covalent bond is formed by sharing of 1, 2 and 3 pairs of electrons are called a single bond. double bond and triple bond respectively. Yes. Okay. Here Cl single bond Cl or double bond O and N triple bond N. Then what is meant by bond pairs of electron and lone pairs of electron? Very important term. Please listen. The shared pair of electrons are called bond pairs of electrons. The shared pair of electrons are called bond pairs of electrons. And the valence electron pairs are not involved in bond formation or sharing are called lone pairs of electrons. In the case of chlorine molecule, the one pair of electron is involved in sharing. Okay? Yes. Yes. One bond pair and 1, 2, 3, 4, 5, 6. 6 pairs of electrons are not involved in sharing. Okay? Then we can say that chlorine molecule has 6 lone pair. Okay. Then the next example, O2. In the case of O2, 2 pairs of electrons are involved in sharing. Then O2 has 2 bond pair, then lone pair. 1, 2, 3, 4. 4 lone pair. Then N2 has 1, 2, 3. Okay, 1, 2, 3 bond pair and lone pair 1, 2. 2 lone pair. 2 lone pair. Then the next important term related to covalent bond is covalency. What is meant by covalency? Please listen. Covalency is the number of electrons. Covalency is the number of electrons which an atom contributes to the formation of covalent bond. Covalency is the number of electrons which an atom contributes to the formation of covalent bonds. That means in the case of chlorine, each chlorine atom contributes 1 electron for sharing. First chlorine atom contributes 1 electron for sharing, and second chlorine atom also contribute 1 electron for sharing. Then here the covalency of chlorine is 1, and then in the case of O2 molecule, each oxygen atom contributes 2 electrons for sharing. Then covalency of oxygen is 2, and in the case of nitrogen, each nitrogen atom contributes 3 electrons for sharing. The covalency of nitrogen is 3. Okay, students? Okay. In my next video, I will discuss the limitations of octet rule. Okay. Goodbye. Study well.